I will stand. Thank you very much for having me here. Look forward to being here. Yes, I want to talk about how we look at high-level energy targets and how we do them operationally. So this is my topic for today. Yes, my name is Anders, and I sit as a global energy manager in a corporate facility. Corporate facility is administrating the energy efficiency initiatives in the company, and we are doing this all over the world. And right now we have more than 0.7 million square meters in our portfolio. So this is what we would have to look at energy for in the future. Yes. So this is the agenda for today. This is the roadmap from how we go from an ambition to actual energy projects. So this is one thing is to have an ambition, but also to be able to realize them is important to have the right set of tools and so on. So as you can see here, we of course have the ambition, which is the overall company strategy, and then we build in a framework around that to make it possible to do this, put in KPIs and so on. And then, of course, afterwards, we need to identify how much energy do we need to save or to invest in renewables to fulfill this framework, and what is the potential? Can we save energy? Do we need to buy renewables and so on? Then we have a method of implementing energy initiatives. This method is, I will come to that later, is describing how we're going from a project to implementing and how we're going to prioritize projects around the world. And then at least I will talk a bit about the energy projects that we look at right now, which is interesting for us. Yes, so this is the overall ambition. It is to make a positive impact for the children, the world that the children will inherit in future. So this is made to a planet promise, and this simply says that we want to make a positive impact on the world. So this is the ambition. This is the overall target or goals for energy, and also for waste and water and so on. But my responsibility is energy. Yes. So here you can see our environmental impact in our production. So as you can see here, we have 75% of our energy and environmental impact is with the suppliers, and then 10% of the impact is in our production, and then 15% is after the products leave the factory. So where we in facility have an influence is of course inside the production, because this is where we have the facilities, we have the ventilation systems, we have the heating, the lighting, and all that which is related to facilities. So this is our focus area within the company, and even though it's only 10%, this is a very important 10%, because if we show that we can do it with the 10%, then it's more easier for us to impact the other 90%, because we need to take the first step to realize this. So this is very important, and there's also a lot of energy to be saved in these 10%. So this is what we actually have to work with. And now I will show you what is the different sectors that we work with. Of course, renewable energy is one thing, and this is both on-site and off-site. Then there is the emission, increasing our efficiency, energy efficiency. Then we also look at supplier emissions. So this is, to be able to come with a demand to the supplier, it's easier if we have a demand on ourselves. So this is important. And then there is some other things. Is of course the material that we use is important, that they are sustainable. So this is a very important role for us. And then of course waste is also important. So as you can see here, the aspiration for us is to be 100% renewable or carbon positive. So this is two things. It's both carbon and energy that we look at. So we cannot just be carbon positive, we also need to be energy positive. So in renewable energy. So this is important, and I will come back to that later. And how we're going to do that, we have some short-term ambitions, commitments that we want to look at renewable energy. So this is on-site energy like solar panels, but also off-site energy like windmill parks and so on. So this is one of the things we look at. Secondly, we look at reducing or increasing our energy efficiency at site so we can produce more with less energy. And of course, this is the most important part, because if we can reduce, we don't have to produce. So this is our main ambition. And then of course, we want to produce the energy locally where we use it. So solar panels and so on site is more attractive than off site. But of course, we cannot produce all our energy on site. So that's one thing. Yes. So these. Good. So how do we go get these 100% renewable energy? This is of course by closing the gap. So when we look at how much renewable energy we have in the company, and this is company renewables, you can see the yellow bar here. So this is how much we have, and the red bar is how much we use of energy. So the thing here is, of course, within 2020 we want to close this gap, so we have as much renewable as we have production. So the first priority will be to close this gap by energy savings. And we already now have some windmills that's getting into action here later on. So these are the yellow bars, and this is of course the main load. But then we're gonna do energy efficiency on some of the rest here, because this is also important. Yes, and of course how we're gonna do that is doing initiatives on site, on our factories, on our offices, and then doing solar panels and off-site renewable energy. So, yes. So how do we identify this gap? Because it's when you're looking into 2020, of course there is a lot of uncertainty. So we need to do some forecasting on this gap, and this is of course a tricky business. So we do it two ways. We do a long-term forecast to see, okay, where is the gap approximately in 2020, and this is of course related to our expectation in growth in production. And when we look at the expected growth, then of course we look at historical data and we make some regressions to see where we'll end in the future. So, and of course including the efficiency that we gain. So this is the long term. Then we do a short-term forecast, because if we have this long-term targets, we also have some year-on-year KPIs that we need to fulfill that have to build up to the 2020. So these short-term savings, we of course look at new facilities, the utilization of the building, because if we start a new factory, we will of course not utilize 100% of the factory, and it will of course use more energy, and that can have a great impact if we turn on a factory in January for the energy consumption. So this is important, and then also using degree days to take weather into account, because if you have a great year with where you don't need so much cooling, then the next year you can have a bad year, and that can have a great impact if you look at a 2.5% savings. So this is important, and of course the difficulties here is looking at uncertainties versus savings. We have a lot of big uncertainties, and of course we need to make sure that we have enough savings to realize the target. So to be able to find out where we can do the savings, we do a mapping of potential energy savings, and you need to know the consumption to be able to do that. And we look at 4 sectors. So offices, which is like normal offices, we look at lighting and heating and cooling, and then storage, which is also standard, and packaging areas, And then there's the big one is our production areas where we, as a facility, we supply a lot of cooling energy and heating and ventilation and all that where we can reduce energy consumption. So as you can see, of course, the red area is where we want to focus our energy, but that doesn't mean that we don't look at the other areas, but there's just a lot to gain in the production side. And of course, when you map the potential, it's important to know your history, what has been done, what has been a success and what has been a failure, because you need to know the already done initiatives all the low-hanging fruits are taken now, so it's going to be more and more complicated in the future getting these savings. To do this mapping of energy, we need to handle our energy data. And we have factories around the world, and it's important that we have the same breakdown structure for all these measurements of energy data. And this is a work in progress because we have old factories, we have new factories, and not all of them is set up the same way with the energy measurements, but this is a work in progress, and we have the ambition of making sure that we can compare each factory, benchmark each other to each other, so we can see how they perform, and of course taking weather into account, because a factory in Mexico and in Denmark doesn't need the same amount of cooling, so this is also an interesting issue. But we try to do it somewhat like here. As you can see, we have a common energy database which collects each site, each production area, offices, and then each system like light, HVAC equipment, production cooling. So it's afterwards we can see if a factory has problem with cooling systems or that we can save on light in a different factory. So this is the process for us to find out how we can realize or increase our energy efficiency by 2.5%. So as you can see the wheel here, we have the energy KPI. We want to save 2.5% energy. And this is the easy part. This is a strategic thing saying, okay, we want to save 2.5%. But how do we do that? We, of course, identify the amount of energy savings necessary to do this. And we need the forecast to say, okay, we're going to use this much energy next year, we're going to produce this much, we're going to have new facilities in operation. This means that we have to save X amount of kilowatt hours. So this is an important thing to be able to realize this KPI. Then we do this global project list where we collect every energy projects that's available, and we take in everything because we make a long list and then we rank them by different priorities like return of investment and carbon and energy savings. So this long list of projects, hopefully, it has much more projects in the list than we need, but it is difficult, getting more and more difficult finding projects. So this list is based on input from local sites or from global projects. And then when we look at how much savings we want to do, we just make a line in this list and say, okay, we need to do the first 10 projects. They're the ones with the lowest return of investment, and that will fulfill our KPI. So that's an important part here. And this was the prioritization process. Then afterwards, it's up to the local factories or sites to take this project that has been chosen and put them into local business plans and into budgets, so they can be realized the next year. And then here, the projects are implemented locally. This is we have project organizations around the world that will do that on site, or we'll get external companies doing that. So afterwards, we can do some after-action review to check if the energy savings has been realized. So the difficulties here is finding projects. All the easy projects are gone now, so we need to step up and be more creative to find projects. Then there is the time slot for implementation. We cannot just go in and turn off the cooling systems. We need to be sure that we have this 5 days a year or whatever is possible to get. And if we don't get this time slot right, then there's perhaps a year where we need to wait, and that has a huge impact on the energy efficiency. And then again, the uncertainty is also a part of it. Yeah. So now I want to talk about the projects that we look at for increasing our efficiency. And one of the newest things that we looked at is groundwater cooling. And this has a COP of around 40. And we have done a test facility in Denmark, and it's a 1 megawatt system, and there's a lot of government issues there that we need to work on and to see if it's possible. But if it's a good case, then there's a huge energy saving in this for us, because a normal cooling system has a COP factor around 4 to 6. So 40 is great, and if it doesn't have any negative impact other places, then it's something that we will look into in the future. Then there's actually a simple one here, is the LED light, which is getting cheaper and cheaper every year, and we need to implement that. But we have a lot of new facilities that has already lights, so we of course cannot just change existing lights. So this is also where we have some issues. Then this is not directly related to energy, but then it is. Like in Mexico, we cannot use a lot of water in our cooling tower, so we want to reduce that amount, and that could we do by close cooling towers, and that will increase the amount of energy that we use, and we are not interested in doing that. So we need to weigh in, can we use different water sources, like gray water, which is water from the sewage that is cleaned. That will save a lot of the energy from the ground. So this is something that we're looking into. Also, cooling machines running on water as a refrigerant. This is also a pilot project that we're running right now. But one of the issues that is important is also engaging people. It's easy to go and do some technical stuff, but the engaging people, understanding the impact they have on the energy and the environment and their daily work, that's important for us, because we can see the different cultures around the world has a great impact. If we look at temperatures inside production halls, we will have in the hot areas of the world, they actually have a lower temperature in production areas than they do in the cold areas, and that's something where I can say that's a culture difference. And we need to look into that, because can we raise the temperature in our cooling water, we can save a lot of energy. And that's why we're doing a climate standard, which look at humidity and temperature, what is the optimal for a factory to run in, and then taking the discussion with people to say, okay, is that a good climate or is it a bad climate? So water and waste are always considered. So when we do a business case for an energy project, we look at the whole environmental aspect. So we don't just throw out tons of great light. So the waste is also taken into account, and we actually have also a global waste manager that's responsible for that. So he will get angry with me if I do a project where I'm going to put a lot of trash into his KPI. So this is something that we need to work together on. So, and also we do every business cases that we do that's over a certain amount, we have an environmental impact assessment. So we make sure that nobody installs equipment that's not aligned with the environmental roadmap that we have. Then there is the on-site renewable energy. Yes, solar panels is great for us. We will do that hopefully in all our sites, because they are optimal for air conditioning. And of course, we will look at the focus on the risk for operation. We don't want to put in electrical equipment that can harm our production equipment. Then we can put in alternative power plants at our site that can use biofuels and utilize all the energy, all the waste heat, and increase our security of supply. And then I'm almost finished. And then we do look at off-site renewable energy. And important there is our grid mix. We want to reduce carbon emission as much as possible, and also do renewable energy. And the countries where we do that has an impact. So this is also taken into account. Yes. And then we look at continuous improving our what we do, taking in best practices and knowledge sharing with the energy managers around the world. We have a specialist team that look only at the best practices. We have a checklist that you need to go through each year to make sure that you look at all the relevant issues. And then, of course, maintaining the existing system is also important. Just not looking at the future, but also looking at what you got, need to run optimally. And then, of course, new ideas and inputs. Yes, thank you very much. That was it.